So we're going to practice a few things with these problems. One is it says to write an equation expressing the fact that hydrogen and fluorine gas react to make gaseous hydrogen fluoride, and then we're going to balance it if we need to, because it says make sure that the equation satisfies the law of conservation of matter, which really means just balance it. So the first thing we have to remember is that there are a few elements that do not exist as a lone element when found in nature, and some of those are the elements like hydrogen, oxygen, nitrogen, chlorine, fluorine, bromine, iodine. And so when we see that this is hydrogen gas, it's not hydrogen by itself. And when this is fluorine, it's not fluorine by itself. It's going to be H2 and F2. So we're going to have H2 gas reacting with F2 gas to make gaseous hydrogen fluoride. So those are little G's. And now I need to see if they're balanced. And so in this case, on the left, I have 2 hydrogens and 2 fluorines. On the right, I have 1 of each. And so I need to make the right equal the left. And in this case, I can do that by very easily adding a 2 in front of the hydrogen fluoride. And now I have 2 hydrogens and 2 fluorines, because that 2 tells me that I have 2 of each. And so now this is balanced. So you're going to do the same thing with the next one, which is to balance each equation. So let's start with balancing the first one, and then you all can practice the other 2. So I'm going to react sodium hydroxide with phosphoric acid, and that's going to make sodium phosphate and water, which is a pretty common acid-base reaction where you form salt and water. So in this case, I have sodium, I have 1, I have 1 oxygen here and 4 there, so that's 5 total. For hydrogens, I have 1 here and 3 there, so that's 4. And then for phosphorus, I have 1. So I'm going to do the same counting on the right, and I'm going to keep my elements in the same order, even though I'm counting them. It's going to feel like I'm counting them out of order, but that's so that I can compare my list. So in this case, I need 3 more sodium, or 2 more sodiums for a total of 3 on the left. So I'm going to put a 3 in front of this sodium hydroxide, and this is going to give me 3 of these. But it's also going to change my amount of oxygens and hydrogens, because I'm going to have 3 sodium hydroxides. So now I'm going to have 3 oxygens here plus the 4 that I already had, so that's 7. And I'm going to have 3 hydrogens plus 3, which gives me 6. So now I need to see what's out of balance. Well, in this case, now my hydrogens and my oxygens are out of balance, but I can see here that there's a factor that they have in common, which is 3. So I'm going to add a 3 here and see where this gets me. Now I'm going to have 6 hydrogens, and then I'm going to have 4 oxygens here and 3 here, which is going to give me a total of 7. And now everything is balanced. And so this is my final balanced equation. The next question says to identify each type of reaction. So in this case, I have phosphorus and oxygen reacting with hydrogen or water to form phosphoric acid. So this is essentially A plus B coming together to form C, something brand new. So this can be called a combination or a synthesis reaction. Either one is appropriate. It just depends on the preference of the author of whatever textbook you have, but combination or synthesis. And that's essentially all you're going to do with these problems. Now, the last one says that the following are redox reactions, but we're not going to worry about oxidizing agents, reducing agents. So what we are going to do is we're going to name what type of reaction this is. In this case, this is a hydrocarbon reacting with oxygen to form CO2 and water. So this is known as a combustion reaction. The last one is potassium reacting with water to form potassium hydroxide and hydrogen. And so this is going to be a reaction that looks a little like this, which we're going to call a single replacement, or sometimes it's called a single displacement reaction, where you have one species replacing or displacing another. And so it's kind of like changing dance partners. B and C are dancing together, A comes along, and then A and C are dancing, and B is by itself.